Welcome to math class. We are continuing on in math 10. We've moved on to area of right triangles, triangles, and trapezoids and parallelograms. I actually need to switch that. The unit is actually quadrilaterals, which consists of trapezoids and parallelograms. Not that we're going to need too much of that, but that's what we're going to be covering today. So let's not waste any time. Let's go ahead and get right into it. So what we're going to be starting with is the area of triangles. Now, the area of right triangles, the formula for the difference between a right triangle and a normal triangle isn't, or other kinds of triangles, isn't all that different. But with right triangles, it's easier for us to figure out exactly which parts of the equation are which. So you'll know that something is a right triangle if they put a little square in one of the corners like this. What that represents is that that angle is 90 degrees or a perfect right angle. Okay, so that's how we can tell if it's a right triangle, if they have that little symbol in there. What we're looking for, though, is we are looking to find out what our base and our height are. In order to do that, it doesn't really matter which one goes first, and that kind of stuff usually generally matters depending on how the triangle is oriented in space. But what we are not looking for is the hypotenuse. Okay, the hypotenuse is the name for the longest side of the triangle. We are looking for the other two sides, the base and the height. If we were to, let's see if we can even try that, we can rotate this triangle on its side, and we can see, if that makes it a little bit easier, what our base and our height becomes. So what we have here is area equals base times height all divided by 2. So in our particular fraction, we have 10 times 240. Oh, they're really being jerks on this question. They're messing around with the units. So we have 10 centimeters, 240 millimeters, which actually winds up being 10 times 24 centimeters gives us 240, which we then divide by 2, which gives us an answer of 120 centimeters squared. Okay, we have to remember that since both these units are centimeters, we have centimeter times centimeter equals centimeter squared. We always have to finish it in squared whenever we're dealing with area. So as you can see, it's a very simple set of processes. You just have to start plugging in numbers for each of the parts of the formula. So let's go ahead and move on to another example. For the next one, we're going to be, let's hide that for a second. I always forget that. We're going to be following the exact same formula, slightly different numbers. A equals base times height over 2. A equals 1.5 times 2 all divided by 2. I believe that's a 1.5. It's a little bit fuzzy and hard to see, but 1.5 times 2, if we go down here to our calculator, right, 1.5 is going to give us 3. So we have 3 divided by 2, which winds up giving us an answer of 1.5. Now that's probably pretty confusing if you already saw the answer down here, but once again, they're trying to mess you around with units. Right? We had centimeters up here, but they, for some reason, are asking you for an answer in millimeters squared. So what we have here is we have 1.5 centimeters squared, which is our area, but we now have to convert that to millimeters. How many millimeters are in a centimeter? 10. So I'm simply, oh, sorry, 10 millimeters to 1 centimeter. So we're going to multiply that by 10, and what we get, oops, sorry, that should be over here. What we get is actually 15 millimeters squared. In this particular case, I think, unless I've screwed up here, feel free to tell me in class if I did, I believe we actually have a misplaced or an incorrect answer on our example there. So you should go ahead and try it, and if you can find a mistake, go ahead and let me know in class. But otherwise, we are going to go ahead and move on to one more example here. The reason I put this example in is because this is a good example of trying to show what we have to do in order to figure out which is our base and which is our height. So we know in this picture, as you can see, we actually do have the little right triangle. So I'm going to go ahead and make this easy on myself, and I'm just going to spin it so that it looks as if it was sitting on that particular flat side. So there we go. Now I've kind of got my square oriented slightly different. And it's really easy for me to tell my base and my height. Okay? I'm pretty sure it's a little bit fuzzy, but I'm pretty sure that's 16. So our formula here is base times height over 2. So we're going to have 16 times, looks like that's 30, all divided by 2. Let's go ahead and pull up the calculator for this one. All right, so we have 16 times 30 gives us, we divide that by 2, we get 240. What's our unit? It is meters squared. If we check our answer here, oh, look, we've already got it right there for us. Our answer is 240. Awesome, we're on the right path. And since we're on the right path, we're going to throw another wrinkle at you. We're going to move on to quadrilaterals. And I'm actually going to give myself a little bit of room to play with here. Quadrilaterals. So there's two different formulas we're going to need for this. We are going to have different formulas depending on which shape we have. So a parallelogram is very different from a trapezoid. Okay? I'll show you the example or the different examples here. So a parallelogram is going to be very similar to a rectangle or a square, but as if somebody punched it in the head and knocked it halfway sideways. These little symbols, when they're on a line like that, what they mean is that they match up with any other line that has the same symbol, and they are the same length. Okay? Same with if we have a double dash over here and a double dash over here, that means that those ones are also the same length. This is a parallelogram. Okay? It's just like a rectangle that's basically just been punched in the head sideways, and it can't stand up straight no more. And that's what a parallelogram is. However, a trapezoid, let me go ahead and clear that out. A trapezoid is much more like a rectangle and a triangle smooshed together, as if a rectangle and a triangle had a very odd love child. So that's what a trapezoid is. Now we actually have two different formulas we're going to use, but by now we should be able to hopefully recognize the formulas are pretty easy to work with. All we really have to do is just punch in the requisite parts of the formula and then solve for it. So we're going to start off looking at our formula for a trapezoid, since that's our first example here. Now this is a little bit hard to read, and it's a little bit fuzzy. Just give me a second, I'm going to pull up a different copy on my other screen here so I can look. Okay, I'll rewrite these so they're a little bit easier to see. So up top, we have 6 we've got 5 over here, and we've got an 8 on the bottom. So our area is 1/2 of our height times one of our bases plus the other base. So what they're talking about here is the two lines that match up, but they aren't quite the same length. So what we got to do is start punching stuff in. So we know what our height is. We know that our height is 5. 1/2 times 5 times our bases are 6 and 8. So 6 plus 8. Now we have to start following our order of operations here. So 1/2 of 5 times 14. 2.5 times 14 gives us 35. And it looks like they're giving us a unit of inches. So we have inches squared. Okay. Now let's move on to parallelograms. And I actually have to correct a small mistake I meant before. These signs do indicate that they're parallelograms, but I forgot to mention that these don't actually indicate that these are the same sides. What they mean is that they are parallel. So that these two lines, if you were to draw them, not my crappy lines, but if you were to draw the two lines from this and these two, if you were to actually draw them straight according to this diagram, these two lines would never touch and these two lines would never touch. It still is essentially just a rectangle that's been punched in the face, and our formula basically reflects that. So if we go back up and we take a look at what our formula is for a parallelogram, area equals our base times our height. Where does that sound familiar from? Hopefully it sounds familiar from doing area of a square and a rectangle, because that's essentially what it is. So for this one, area equals our base times our height. So we have to once again rewrite some numbers in here since they're a little hard to read. Over here we've got a 7, and down here we have an 8. Looks like we're using inches as our unit. So if we head back over to our formula, I'm going to punch in 8 times 7, which gives me 56 inches squared. Okay? Looks complicated. The formula is super easy. I highly, highly recommend writing down that formula, and this formula somewhere in your notebook or your phone, somewhere where you've got easy access to it. But other than that, I will see you in class.